Hello and welcome to DataCast Solutions, Statistics and Data Mining 101 using KNIME. Hello. This chapter now begins the section on data mining methods. And we're going to begin this discussion with just an introduction to this topic. Data mining, or knowledge discovery from data, KDD, is the non-trivial discovery and extraction of implicit and previously unknown and potentially useful patterns in data. And I say that carefully, potentially useful. Not all patterns are useful. In fact, the patterns have to represent something that it's subjective to human interpretation, and you apply value to what it is you've learned in that pattern. Suppose, just as an example, I showed you that the most common item purchased at a new hardware store opening is toilet bowl cleaner. That happens to be, by the way, a true fact. Now, is that a pattern in data? Yes. Is it useful? Is there something I can do about that? Well, potentially, I suppose I could make sure it's available right when you walk in the store. But other than that, there's not a whole lot of value to knowing that. This, in fact, is the art of data mining. There's a science side where we compute numbers. The art is the human judgment that we apply to these patterns that makes it valuable. What data mining is not going to do for you, it's not going to sit on top of your data and automatically discover patterns and point you to things that need to be done. It's just a tool. Data mining assists a business analyst with finding the patterns and relationships, and it doesn't tell you what to do with that pattern. And further, just because I discovered a pattern in historical data, it still must be verified in the real world. Another very important topic we talked about when we talked about correlation. A predictive relationship found in mining does not mean that the cause of action or behavior. For example, if you determine that males with incomes between $50,000 and $65,000 are more likely to buy health insurance, well, while you can take advantage of that pattern in your business model, you don't assume that any of these factors are what caused them to buy insurance. It's just an indicator of them buying insurance. So what's the difference between statistics and data mining? Why did I spend so much time teaching you basic elementary statistics if the class is about data mining? Well, the disciplines of data mining and statistics do overlap quite a bit. A lot of the tools used in statistics are used in data mining. In fact, some people like to say that data mining is a subset of statistics, but that's an unrealistic assessment of what it is, because we make use of ideas and tools and methods and methodologies from other areas, especially database technology, machine learning, artificial intelligence. They're all heavily concerned with areas of modeling and data mining that a statistician has no interest in. You will discover that statistical procedures are a major part of data mining, particularly in the process of assessing our models. That's where they come in most frequently, when we've created a model and we want to understand how accurate the model is. That's something statistics is great at. So statistical tests are used to validate the machine models and machine learning algorithms. Nevertheless, there are parts of statistics that are used in the development of the model, especially in data exploration. We use descriptive statistics and visualization, so we look at things like averages, measures of variation, like variance and standard deviation, counts and percentages, and we might create crosstabs and simple correlations. They're useful in us understanding the structure of the data, and that's important during the discovery technique, where we're looking at our data to understand it before we begin trying to develop models. So we'll use visualization tools like histograms, box plots, scatter diagrams, and other types of visualization tools. Other statistics used in data mining include cluster analysis, where we try to to cluster data around homogeneous groups. We certainly do correlation analysis, where we're measuring the relationship between a dependent and an independent variable. That's going to be heavily used in predictive modeling. Further, statistical discriminant analysis is heavily used as part of predicting membership into a group. So, are you going to be a major donor or not a major donor? Is an employee going to quit or not quit? Customer leave our organization or stay with us? And finally, factor analysis. It's very useful in understanding the underlying reasons for correlations among a group. It's to reduce the number of variables that are necessary to detect the structure and identify the patterns. What I'd like to do now is talk through each of the major functions of data mining and how it relates to the statistics that we've been studying up until this point. And so to begin with, let's start with the function of data summarization. This is part of the exploratory process, and sometimes that's all we do is just this much, but it's generally carried out early into the process. And it's just to help us understand the nature of the data that we're going to be exploring. And so we might use simple descriptive statistics, like measures of central tendency and so on, as well as visualization techniques. Those are the types of statistical functions that a data miner would perform in the data summarization tasks. One of the funnest functions, at least for a lot of people, especially when using KNIME, are the classification functions. This is when we assume that a set of objects, attributes, and features about a person or a place or a thing belong to different classes. And the class label is generally going to be something very discrete and qualified. For example, large, medium, and small. Or maybe it can be just a simple yes-no predictor, like is a customer going to churn or not? And they're generally used in predictive modeling. And so the statistical features you'll see are most likely going to be things like discriminant analysis, decision trees, rule induction methods, and genetic algorithms are some of the statistical functions that would apply to this data mining function. Now, the prediction function of data mining is very similar to classification in terms of especially the processes you go through. But the difference is that the class is not qualitative like small, medium, and large, but instead is a continuous one. For example, predicting movie revenue based on budgets and sales and advertising and book sales and things like that. This type of problem is known as regression, and it deals with usually time series data, also called forecasting. So you're going to use the statistical processes that you're going to see involved here are going to be regression analysis, decision trees, neural nets, that type of thing. Now, segmentation function is separating the data into what we might consider interesting or meaningful subgroups. We call this clustering. And the analyst might hypothesize certain subgroups as relevant to business processes or questions. There are a number of automatic clustering techniques that can detect previously unsuspected or hidden structures in our data. So the statistical functions that you'll see performed within here are things like clustering techniques, visualization, and neural networks. The dependency analysis function deals with finding a model that describes the significant dependencies between different data elements in your database. Dependency analysis has a very close correlation and connection with classification and prediction models, because that's exactly what they are. They're trying to understand the dependencies variables impact on the independent variables. So correlation analysis, regression analysis, association rules, these are the types of statistics techniques that are going to be used in this data mining function. Sequence analysis function, SQL analysis is modeling sequential patterns in data that you begin to see. The goal is to understand the states of the process generating the sequence, or extract a report from deviations for trends over time. So best example of something like that would be credit card fraud. A typical person who steals your credit card has a very specific pattern. The very first thing they do is they charge gasoline with it. Then they usually go to a big box store and charge about a $200 item with it. Then they go to an even larger store and they try to do a $500 to $700 item. When the credit card company sees that pattern, that's an indication that there may be credit card fraud going on. Link analysis is actually one of the funner functions as well, because it determines the relationship between fields in the database, usually association rules, that items, for example, are commonly purchased together. The focus is on deriving multi-field correlations, or multivariable ANOVA, to support the confidence thresholds. As an example, this might be that you're looking at a hardware store and you discover that people who buy hammers almost always buy nails. Now then you get to interpret that information, and what do? Do I put the nails close by the hammers, or do I put them on the other end of the store so I make you shop a lot through my store to look at other items before checking out? So this table is just a summary of the functions that we perform as data miners and data analysts across the top, and the statistical techniques that we've been covering through the prior chapters, and which of those techniques are going to be used through which of these functions. Now the taxonomy of those functions, I like representing it as a tree to help people visualize it. What do? Well, for a start, we do verification. That's usually hypothesis testing, the chi-square goodness of fit, analysis of variance. We're trying to understand if our models work. But we also perform discovery, and discovery could be just descriptive techniques, clustering, summarization, visualization, or we do prediction. And prediction can be in the form of a regression model for continuous variables, or classification for nominal variables. And in classifications, we're going to build neural networks, Bayesian networks, decision trees, SVMs, and all of these are terms we're going to cover in each of the various chapters. We're going to show you how to build all of these predictive models as part of this class. And let me get this out on the table right now. Within those predictive models, there is no, quote, best technique. Each technique has its own strengths and weaknesses, and it really depends on the content and the distribution and the skew and everything else related to the data. You don't rely on one predictive model. You will build many predictive models, and then you will choose one of those models that produces the best result. You'll see in the course of this class, what we're going to do is use a continuous example, and we're going to learn how to build all kinds of different models, a Bayesian network, a decision tree, a neural network, and we're going to look at the scores of each one of them to figure out which one, given our data, is going to be the best model for predicting an outcome. Now, there are very definitely some challenges that reflect in our work. Number one, the most important, is the size of our data sets. We're getting high dimensionality. There's lots of spurious patterns that are not valid or actionable, and so we have to find the actionable patterns. We'll also find overfitting as a problem, and that's something we're going to talk about in more detail, but basically it means the difference between learning a pattern and memorizing a pattern by studying the data too hard. Missing data is always going to be a problem because it causes applications, were designed without discovery in mind, so there's problems with data that's missing. Noise, which is the uncertainty reflected in the randomness of our data. In other words, extreme outliers or data that isn't quite right compared to everyone else. I've never bumped into a company that says our data quality is perfect. Everybody complains about data quality in their company. Now, understandability, the ability that those patterns discovered have to be understandable by humans. Purchasing beer and diapers together seems to be the most common combination at Walmart. Well, that's interesting. How does that help me? And integration of data mining into our daily processes is another challenge. We can learn to build the model, but building it into our processes in the business will be another challenge. And more emphasis on human interaction and not total automation is going to be a challenge. That we need to get things automated so things just happen and don't require a human being to intervene. That completes this chapter of the class. Feel free to move on to the next chapter.